Okay, now let's take a look at our example 2. So you have a bucket connected by a rope wrapped around a wheel. If the angular displacement of the wheel is theta equal 0.5 t to the power of 3 plus 15t radian, where t is in seconds, determine the velocity and acceleration when t is equal to 3. So first thing to notice, is this a constant acceleration problem or not? We already know that it should not be a constant acceleration. Why? Because the displacement, if you derive it twice, you will still have a t in it, meaning as t changes, or the time changes, you will have a change in the value of a. You can predict that lah. So you cannot use the equations for constant acceleration. What do you need to do? You need to use your derivative lah. Okay, so let's try to solve this problem. First, you need to find the angular velocity. So angular velocity omega equal to derivative of the angular displacement. So what is the derivative? If you derive it, you should get 1.5 t to the power of 2 plus 15. Right. 0.5 t to the power of 3. You remove 1 power and then you multiply by 3. You multiply by 3 and remove 1 power lah. Plus 15. Because 15t you derive, you get 15, right? So this is the equation to get your angular velocity. Then what about angular acceleration? You derive your angular velocity, and deriving that, you should get 3t radian per second square. So like I said, this is not a constant value. As time goes on, this will become bigger and bigger, so not a constant value. So in that case, you need to find the velocity and acceleration of the bucket when t is equal to 3s. So this is the bucket. We want to know the velocity and acceleration. So this is a linear movement, so not a rotary movement. So how do you convert from a angular movement to a linear movement? Because we only need to find the velocity here and the acceleration here. So that can be found by using your equation v is equal to angular velocity times r. This is why actually you use your radian. So r is the radius, which is given here 0.75. Similarly, for acceleration, I'm sorry, not alpha. So the acceleration a equal to alpha angular acceleration times the radius. The problem now is you don't know the angular velocity and angular acceleration. How do you get it? This given here, you want to find the velocity and acceleration at t equal 3. So what you need to do, you just put the value of 3 inside here, inside the 3 and inside the t. Yes. So for v, the angular velocity will be 1.5 3 to the power of 2 plus 15 times the radius which is 0.75, and angular acceleration 3 times 3 seconds times the radius 0.75. So you should get v is equal to 21.4 meter per second, and acceleration will be equal to 6.75 meter per second.